So according to Hooke's law, force and extension are directly proportional within limit of proportionality. Then there's a formula related to a Hooke's law which relate force, extension, and there's also another term which we call spring constant. What is the meaning of spring constant? According to Hooke's law, this is a formula of Hooke's law that force is equals to spring constant multiplied by extension. What is the concept or what is the meaning of a spring constant? Spring constant refers to spring constant means amount of force required to produce 1 centimeter or 1 millimeter or 1 meter extension. It depends on what unit we are taking extension. So how much force is needed to produce 1 centimeter, 1 millimeter or 1 meter extension? We call that as a spring constant. Example, we have a spring which is having a length of 5 centimeter. So this is spring and this spring is having a length of 5 centimeter. We attach a load say we attach a 10 Newton load and the new length is 7 centimeter. What is the extension of this spring? How much the spring extended? So it is extended by 2 centimeter. Now what is the definition of spring constant or what is the meaning of spring constant? Spring constant means force required to produce 1 centimeter extension. So a force of 10 Newton here in this example, a force of 10 Newton is producing 2 centimeter extension. What is the force to produce 1 centimeter extension? If 10 Newton is producing 2 centimeter extension, how much force is needed to produce 1 centimeter extension? Force required to produce if 10 Newton force is producing 20 centimeter extension, how much force is needed to produce 1 centimeter extension? So that is 5 Newton. So 5 Newton is the force needed to produce 1 centimeter extension. So what we will say the spring constant is 5 Newton per centimeter, or per centimeter you can write slash Newton per centimeter. So the force required to produce 1 centimeter extension, that is known as the spring constant. Higher the value of a spring constant, it will be difficult to stretch the spring. If it is having a smaller value of a spring constant, it will be easy to stretch the spring. So example, if we say we have two springs, one is having a spring constant of 15 Newton per centimeter, spring A. Spring B is having a spring constant of 2.5 Newton per centimeter. The question is, which spring is difficult to stretch? So spring A, that's right, spring A is difficult to stretch because we need a 15 Newton to produce 1 centimeter extension. And here in spring B, we only need 2.5 Newton to produce 1 centimeter extension. So we say that spring A is having a higher spring constant, means it will be difficult to stretch. So the correct answer is A. Or we can also use the term, we can say that spring A is stiffer than spring B. And the term stiffness means like you need a greater force to produce a small extension or small change in length. Is it clear the concept of a spring constant? The meaning of a spring constant means that how much force is needed to produce 1 centimeter extension. So the formula for a Hooke's law, force is equals to spring constant multiplied by extension, or we can say F is equals to K E. And spring constant, how we denote spring constant? It is represented by K. So force is denoted by F, spring constant is denoted by K, and extension is denoted by E. So F is equals to Ke. So if I say I'm applying a force of 2 Newton, so if you apply a force of 2 Newton and it produce extension 20 millimeter. So what is the spring constant here? So F is equals to Ke. F is a force which is 2 here. K is a spring constant and E is the extension which is 20. It's 20 is multiplied, other side it will divide. So K is equals to F divided by E. So it will be 2 divided by 20, which is equals to 0.1 Newton per millimeter. So it means we need a force of 0.1 Newton to produce 1 millimeter extension. From the graph, we can also calculate from the graph as well, but we always calculate for a linear part. Like if I want to calculate a spring constant, I can calculate a spring constant only for a straight part where it is obeying a Hooke's law. So you can take any force or any point you can take. Example, you took this point as 30. Any point within a straight line you can take. So the force from that point, that is 3, and the extension is 30. So what is the spring constant here, or K? So K is equals to F divided by E. The force is 3 and the extension is 30. So 3 divided by 10, 30, you will get 1 by 10, or which is equals to 0.1 Newton per millimeter. So you can take any value, you will get the same answer. Like example, if I took this point, the force is 1 and extension is 10. So if I get the K, it will be 1 divided by 10, again 0.1 Newton per millimeter. So for a straight line, I can take any point and check the value of the force and extension. I will get the K, and that will be same within the linear region. Is it clear how to calculate the spring constant? Is it clear to everyone? Now some questions, examples related to Hooke's law. Okay. In this question, I want everyone to solve and state the answer in a chat. A spring has an original length of 3 centimeter. Okay, that's the original length, means the length of a spring without any load, like nothing is attached to the spring. and it is 3 centimeter long. The total length of a spring, it is extended to a total length of a 5 centimeter. So it become 5 centimeter when we attach 8 Newton. Calculate the spring constant. To calculate the spring constant, you can use the screen annotation to state the answer as well. What is the value of the K here? You can either use the chat or a screen annotation to state the answer. We need the spring constant K, which is F divided by E. The force is 8, extension original length is 3, new length is 5. So what will be the value of the K? Extension, Abdullah, the total length is 5. So what is the extension here? Originally it is 3 centimeter. The total length is now 5. So how much is extension? So when you work out, it will come out as 4 Newton per centimeter. Why 4 Newton per centimeter? As you read the question, they mention when the spring was not having any load, it was 3 centimeter. When we attach 8 Newton load, it is extended to total length, like the total length become 5. Originally it is 3, with the force of 8 Newton it become 5. So we need a spring constant. To get the spring constant, K, this is force divided by extension. So we applied a force of 8 Newton. And how to get the extension? The stretch length minus the original. So 5 minus 3, the extension is 2. So 8 divided by 2, that's equal to 4 Newton per centimeter. Is it clear, this example? Yes, Abdullah?
Sir, extension and spring constant are different things, right?
Yeah, spring constant means how much force is required to produce 1 centimeter extension. And extension means how much increase in length is there from the original value. So to get the spring constant, we need the force and we need extension, because the force applied divided by extension give us a spring constant. The force which we applied is 8, and according to the question, originally the spring was 3 centimeter and then it become 5 centimeter. So the how much is the extension of the spring? The extension of the spring is 2 centimeter. So 8 Newton produced 2 centimeter extension. So it means that 1 centimeter extension will be by the 4 Newton force. That's why it is 4 Newton per centimeter. Is it clear? Another example, not the, another example, actually it's a part of the same question. Assuming that the limit of proportionality of a spring is not reached. If this limit of proportionality does not reach, it means it is obeying the Hooke's law. The same spring is there. Now calculate the force needed. Calculate the force needed, extended it to total length of 6 centimeter. So the question is how much force is needed so we can make the length 6 centimeters. So originally the spring is 3 centimeter. This is a continuation of the question. Originally it is 3 centimeter, then we want to make it 6 centimeter long. We need this force F, and the K is already known. K is 4 Newton per centimeter, that's fixed. How much is the extension here? If we want to make the spring 6 centimeter, the original 3 centimeter spring, we want to make 6 centimeter long. What is the extension here? Originally the spring was 3 centimeter and we want to make 6 centimeter long. How much is the extension? So it will be 3 centimeter. Now we need the force. So how to get the force? You can use the ratio or you can use the formula. Look, F is equals to KE. So K was 4 multiplied by extension is 3. So 4 multiplied by 3, you will get 12. That is one way. There is also another way. You can use the concept, as you know, force and extension are directly proportional. So first, when the force was 8 Newton, how much was the extension? 2 centimeter. But now the extension is 3 centimeter. What should be the force? So you can use the ratio. If 2 centimeter become 3 centimeter, it means it is multiplied by 1.5. So if extension is multiplied by 1.5, force will also multiplied by 1.5. So 8 into 1.5, you will get 12. Or you can use a formula F is equals to KE, where K is a spring constant, that is a constant value for the one spring, and E is the extension. So K multiplied by extension, you will get the force. Is it clear? So this was about Hooke's law. Another a simple example related to Hooke's law. Example: you have a spring which is not stretched, and I say this is having a length of 5 centimeter. You attach a 10 Newton load, and its length is 7 centimeter. So if length is 7 centimeter, the extension will be 2 centimeter. Now what you did, the same spring, you put it inside the water or a container which is filled with water. My question is, what will be the extension or the total length of a spring? Or example, the total length first. What will be the total length of the spring when we attach the same load but when we place the object underwater? Will it be more than 10, will it be more than 7, less than 7, or equal to 7? What will be the total length of the spring? Will be more than, less than, or equal to 7. So the correct answer is it will be less. It can be any number, but it will be less than 7. Why it will be less than 7? Because the water apply, whenever objects are there in the water apply an upward force, which is we call that as a upthrust. So water will apply an upward force and the weight is downward. Weight is 10 Newton down. So 10 Newton force is downward, the weight. An example of water is applying a upthrust or upward force or reaction force of the water is 2 Newton. So what is the force on the spring? The force on the spring is actually 8 Newton. But here, because air is negligible upthrust from the air is not applying an upward force or negligible upward force. That's why here the force is 10 Newton downward. Here the force is 8 Newton downward. That's why the extension of this spring, which is underwater, will be the length of this spring, which is underwater, will be less than 7. It can be any number, example 6.5. So extension will also be less than the original one, so it will be 1.5 centimeter. So whenever an object is there underwater, inside the water, or on the surface of the water apply an upward force. So the resulting force on the spring, the force on the total force on the spring decreases, because there is upward force and downward. So the total force is less on the spring. That's why the extension will also decrease. Is it clear, this concept? So today we discussed the effects of the forces, as well as we did some examples related to Hooke's law and the statement of the Hooke's law. Any question related to the class today? The next session we will do questions from the Hooke's law. Any question or a doubt related to the class? So I'll end the session and share this recording with you.